Alright, what's up guys? In this video we're going to pick up with some partial differential equations. We're going to be talking about second order partial differential equations. We're asked to solve the following partial differential equation. So we're given d squared z over dx squared is equal to 3 times d squared z over dy squared. So this is a second order partial differential equation. Most PDEs cannot be solved analytically. And there's a variety of different techniques to solve them, such as separation of variables and so on and so forth. But in this particular example, the first thing that we're going to do is we're going to subtract 3 times d squared z over dy squared from both sides here. So we'll have d squared z over dx squared minus 3 times d squared z over dy squared, and that's going to be equal to 3 times d squared z over dy squared minus 3 times d squared z over dy squared. And what that does is that gives us d squared z over dx squared minus 3 times d squared z over dy squared is equal to 0. Now recall here that d is the partial of z with respect to x, and that d prime here will be the partial of z with respect to y. So let's substitute that in. So we'll have d squared z minus 3d prime squared z is equal to 0. We can basically kind of factor out a z. So in that case, we'll just have d squared minus 3d prime square multiplied by z is equal to 0. So you notice we had two z's over here, so we could easily just factor one of those out. And now, much like we've done in previous videos with just ordinary differential equations, second order ones, we would find the roots, which we would attain by finding the auxiliary equation. In this case, we're going to find the auxiliary equation here as well. Or the characteristic equation is another name people will call it. So again, this is a second order PDE with constant coefficients. And the auxiliary equation here is just going to end up being m squared minus 3 is equal to 0. If you don't use m and you prefer to use r, that's fine. Some people use r, some people use m. If you want to use r, that's fine too. And basically what we need to do is you need to find the roots here. So what you can do is add 3 to both sides, so you'll get m squared minus 3 plus 3 is equal to 0 plus 3, which gives us m squared is equal to 3. Take the square root of both sides, and we'll get m is equal to plus or minus the square root of 3. So we could basically say that these would be the roots here. Okay. Now again, if you prefer to do it with r, because I've seen people use r instead of m, that's perfectly fine. So if you write it r squared minus 3 is equal to 0. So r squared minus 3 plus 3 is equal to 0 plus 3. You get r squared is equal to 3, taking the square root of both sides. Again, you'll get r is equal to plus or minus the square root of 3. So if you use r for the auxiliary equation, that's fine, or m, either works. I used m though, but you can use r. Okay, so all we have to do here is write down our final answer. So we don't have complex roots or anything like that, so we know the form of the solution. So everything is a function of z. So here z is going to be equal to phi prime, or excuse me, phi sub 1, excuse me, multiplied by y plus the square root of 3x plus phi 2 y minus the square root of y minus the square root of 3 times x. And that would actually be our solution. And recall that psi 1, not psi, but phi 1 and phi 2 there would be our arbitrary constants. Okay, so that's your final answer. All right, let me know if you got any questions. I will see you next time.